So in this question, we're told that a car of mass 1,500 kilograms is towing a trailer, and the trailer's mass is 1,000 kilograms. The way that it's towing is with a light, inextensible rope. The car is experiencing a constant air resistance of 200 newtons, while the corresponding constant air resistance on the trailer is 300 newtons. The car and the trailer are modelled as particles, with the tow rope remaining taut and horizontal throughout the motion. So there's a lot of information there, which, as always, needs to be modelled as a diagram. So let's get the diagram that matches. Here's just the road. I'm just going to draw two rectangles for the car and for the trailer. Now I'm going to choose the direction of motion as towards the right, which means the car is here on the right hand side and the trailer on the left. Just going to label the masses that we've been given, which we can turn into forces if necessary. We've been told the resistive force on each of these. The resistance on the car, this is air resistance of 200 newtons, moving in a direction opposite to the direction of movement. On the trailer, there's air resistance of 300 newtons, moving in a direction opposite to the direction of movement. And because we know that we're in motion, this rope also has some forces in it. It's going to be tension. As the car's moving forward, it's pulling the trailer towards the right. As the trailer is being pulled, it's resisting what the car is trying to do. It's slowing the car down from any movement it would do independently of the trailer. So here's the two tension forces. As we continue to read, we're told that the driving force acting on the car is 750 newtons. Okay, I think I have enough information to find any unknowns about this situation. Question first asks us to find the acceleration of the system. So just like always, I'm going to try and get two motion equations which are going to help me to solve for an unknown acceleration and solve for an unknown tension. So let's go. I'm going to start with the car and think about all of the forces acting on the car. The resultant force is going to be the positive force, 750, and the negative forces, 200 and t. They're going to equal the mass multiplied by that unknown acceleration. And I can simplify that to be 550 minus t equals 1,500a. We can do the same thing now for the trailer. The positive force t minus the negative resistive force 300 equals 1,000a. Okay. As usual, this is the technique to use. We're going to add these two motion equations together. That's going to eliminate t, meaning we can solve for a. So as we add them together, as we sum them together, we get 250 equals 2,500a, and in an instant, we know that a is 0.1. Okay, if a is equal to 0.1, we just need to substitute that into one of the previous equations. T minus 300 equals 1,000 times 0.1. I can do a lot of this in my head. T minus 300 equals 100. That means that T must equal 400. The tension in the rope is 400 newtons. Okay, so this technique will always help you to find the acceleration and the tension if you have all the other information.